The whole world is jumping on the Ghibli AI trend, creating stunning arts with just a click. But let's be real, not everything AI gives you is perfect. Just like those AI generated image can have those weird glitches, your Python code can have hidden bugs too. So why not learn how to debug it like a pro? Let's deep dive right into the video. So why error handling and debugging? Well, if you want to impress your teammates, if you want to impress your girlfriend who is doing a coding assignment and you know how to debug, you can just impress her. Or if you want to impress that particular colleague you like, So, coding, and if you know how to debug, is a master skill that you must know. So that's where I'll come in. I'll help you how to debug like a pro. Let's know how to do that. Firstly, we'll talk about try and except block. Already we have covered it in the module 4. So let me just run and show you. Okay. Let's do the zero error first. See, when I divide 10 by 0, it cannot be because zero division error shows up. The exception calls and it prints error cannot divide by 0. Okay. So there are more built-in exceptions in Python, such as this: index error, assertion error, index when invalid index of the list is accessed, assertion error when assertion is failed, attribute error when the attribute reference is not right, import error when you have imported some module which is not yet installed, so because that's why import error happens, and so on. You can check this out. You can pause the video and write it, take a screenshot. Then coming to the silent failures and how to debug those invisible errors. So what are silent failures first? They are data loss due to unhandled errors, function returning none instead of expected values, incorrect result due to unnoticed logic error. Maybe you have done everything right, but the logic isn't great. So that's why the results are incorrect. That's those things are silent failures. And how to debug them? Let me tell you. We can use logging instead of print statements. People generally use print statement, but those are for simple Python codes. Is for complex and more project oriented, we can use logging. It's also a built-in module which helps track error in real time, even if program doesn't crash. Even if crash, it does record that also. So we can do, it's like a breadcrumb trail, so that if anything goes wrong, we can just determine where is the cause. See, in big projects, things are interconnected, and if something happens to the running of that code, we want to know where the error happened, right? And we cannot do it just by looking at the code line by line. There are thousands of code, so pinpointing the location is crucial, and that's where logging comes in. It will log certain execution of codes so that we know if something happens, that's where the execution happened, and that's where it didn't work properly. Okay. So first we'll import the logging module. Okay. Then we'll use its basic config function where we'll set the level logging.debug. There are 4 5 levels. We'll talk about it. So first level is debug. Now we'll create a file name called debug.log where all the logging will stored. It's like print statements, and file mode is write. Okay. I've already taught that in the file chapter. So W is the write mode. So now we have written our function, and in the except block, we have logged error attempted to divide by 0. Now result divide 0. Let's run this code. Okay. See, it created, if it isn't present, then it creates a debug log, and there error root attempted to divide by 0. Okay. So it outputs none if the silent failure but logged. Basically, it fails to do that, but the result is it has to show something, right? So it is showing none. So Python logging levels. Okay. First one I have already told you, debug. It is basically diagnostic information for developers. Now the second one is information where we'll indicate normal operations that the program is running as expected. Warning, something unexpected situation that might come up and it needs our attention. Error, basically an error happened in your code. And critical, it's something which could cause a program to crash or become unstable. So it signals that. So these are the different levels of the logging we can use inside our coding so that we can debug it whenever happened. Okay? Some for example, if you have written a code, suppose this one, okay? If I'm not writing the logging things and everything, if we run it, it shows an error. Now we do not know where the error is, right? Here you can find because it's a small code, but in long lines of code, you cannot just pinpoint some error, right? There's a whole project behind it. That's why logging is very useful. It will detect in which line where is the place where this happened, and you can just debug it there. So it's faster, it helps developer to do it quicker, and also saves time. Now, detecting silent failures with assertion. So assertion helps catch logic errors early in the development. Suppose we are asserting something to a variable, okay? And if we try to do some assertion things, like here we have assigned assert, then price is greater than 0. If the price is not greater than 0, it will show an assertion error. It's useful, not in many ways, but you can use it if you need. Another one, there's a Python built-in debugger known as PDB, allows you to step through your code interactively. Okay, let me show you how it is done. So these are the commands that you need to run. Okay, let me first run this one. It's a basically zero division error. So let me show you how it is done. Okay, first let me print the value of a. We can just use p space a. It shows 10. Okay, starts the debugging here. How to write that? First import pdb, then write your function as it is, and you can use this statement pdb.setTrace wherever you want to start the debugging. Okay, so now let's run the next line. We'll use n. Okay, the result isn't done because zero division error happened. Now let's just quit it. So now you know how to do a debugging using Python's built-in debugger. It's very fast, very easy, and it saves time also. So it's another method. Now you can do it. Coming to debugging performance bottlenecks. Okay. So what are the things that are making your code slow? They can be insufficient loops, recursion, unoptimized database queries, and heavy memory usage. So first, how to identify a slow code? We can use cprofile, a built-in module in Python, to find slow functions. It will track execution time of different function. Also, this is the module which measure function execution time, helping identifying slow parts of the code. So import cprofile, you have to install it also. So use pip install cprofile, then write your code as it is, and then run the code inside cprofile. Okay, so this statement is used, cprofile.run parenthesis, inside that the function is written in quotes. Now let's run this. Here it shows that the function call, four function calls in 0.478 seconds. Okay, the slow function is called, the whole module is called, the whole thing, built-in module is there somewhere, which is being called inside the cprofile, which takes negligible time, and the profiler is closing himself, so that takes 0 seconds. Okay, so these are the things. N calls means number of times the function is called, total time means total time it took, per call means total time by n calls. Okay, so that is same. Cumulative time, basically if there is any sub function, then the whole function took how many time, it's a cumulative time. Okay, that is also same as total call. And another per call, which is cumulative time divided by n calls. So that's the whole thing about it. Here I have written all this, you can go through. Now we coming to the time it module. It's a module which benchmark your code execution. It will help how long specific code snippets take to execute. Okay, so let's start. We will import the time it module. We'll make a setup code such as this one. Okay, inside quotes, x is equals to list range 1000, means we are making a list of 1000 from 1 to 1000. Okay, 0 to 1000, 0 to 9999. And test code, which is the sum of all those numbers. Okay, now execution time. So let's use the time it module, time it dot time it function. Inside that we have used the system, basically test code, where the test code is executed, which is the sum. Now the setup code, where the x list of 1000 where numbers is being stored. Okay, and it is being run 10,000 times. Okay, so that's the execution time is stored in the execution time variable. Let's print that. Okay, it's 0.09 seconds. That's really fast. Okay, now how to optimize slow code. You can use list comprehension instead of for loops. Basically they will run in the back in C, so it is very fast. You can use numpy pandas for faster calculation. They'll calculate in one go for. Okay, and you can use caching to avoid redundant computation. Basically it stores one an operation results, and you do not have to do another redundant operation to calculate that result again and again. So it's make the code faster. Handling in APIs and web scraping. Basically how to handle API errors. And what is API? It's application interface which connect one server to another. We can communicate between one server to another. Okay, client connects to server, server connects to server, everything is done through API. Okay, so what kind of errors we can face? First is network issue, no internet, server downtime, server is down 503, rating limit 429. Basically too many requests causes the server to overload and it just doesn't work. Supposingly invalid JSON response. Basically when we are calling an API, it gives us wrong JSON response. It can cause a crash in the program. Okay, so how to handle those errors? Let me show you. See this program. Okay, first we'll import request, we'll set the URL link, we'll use try and accept block. Well, in try and block we'll get the URL, we'll get response from URL, and we have set the timeout to 5 seconds. If under 5 seconds it gets a response, it's okay. If it doesn't, then it will show a timeout error. Okay, if it gets a response, then it will check whether it has HTTP error or not. Basically whether we can access it or not, whether it's a bad request 40 400 403 forbidden, whether it's not found. It just check for the status of the responses that we get from the URL. Okay, now we have parsed the response from JSON to dictionary in the data. It's basically a dictionary. Okay, now we print those data. Okay, if in case there's a problem that happens, okay, if there's a exception happens, if there's an error happens, it will raise such as this. First one is request.exceptions.timeout. We'll use that. It handle timeout issues very correctly. Okay, it will show API request timed out. It doesn't show any responses, so it timed out under over the 5 seconds. Now another one is request dot execution http error as error. Basically, this error handles HTTP errors such as bad request, forbidden, not found, internal server, all those kind of things are handled by this error exception. Okay. Now, if any other exceptions are there, it will cache that only using request exception as error. Okay, where it caches all other request related errors such as DNS failure, domain name server failure, connection error. All these kind of errors are come under request exception. Okay, so that's how we handle API errors. Let's do that. See, it gives us a title, it gives us a body as a JSON. It's a lorem ipsum basically. So you get the point what I'm saying. All those things I've told you, it's written here. No worries, you can just read it again. Now, how to avoid API errors? So we can use exponential backoff to retry failed request. Basically, whenever we try to call an API, if it get fails, it will wait for 1 second, 2 second, and 3 second, depending upon number of times we try to access the API. We call the API so that it won't spam the server and it won't slow down the whole program. Now we can use API caching to reduce unnecessary call. Basically, it will store temporarily API responses to improve the performance of the code. Another is header and user agent to avoid bot detection. Some API block the API request if it detects a bot. Okay, some Python script looks like a bot and they just block off it. It needs a user agent, so we can use custom user agent so that it will detect as an user agent rather than a bot, and it will get you that response you're looking for. Now, how to handle scraping errors? Okay, in order to web scrape something, we could find some errors. Okay, so how to handle those, how to debug like a pro, how to debug a web scraping error like a pro. We can use Beautiful Soap, which is a Python library, popular Python library for web scraping and parsing HTML and XML documents. Basically, it will broke down those HTML documents into tree-like structures, which can be used to, navigate through the extracted data and use them. Okay. So how to write those? Let me show you here. We'll import the BS4 module. From that, we'll import Beautiful Soap. Okay. Now also we'll import request because this is a URL thing. Now we'll go to try and accept block. Here, in order to get response, we'll use the request.get function where URL is the URL link. Then headers is equals to header where you have used user agent such as Mozzarella 5.4. We can use Chrome, Windows, whatever. Okay, any web browser user agent so that bot detection doesn't happen. Earlier I have told you. Now soup is equals to Beautiful Soap. Under that, we have written the response.text. Every response that have come is converted to text, and then we have used html.parser. Basically, this line, what does it does is it parse the HTML response that we got into tree-like structure. Now we can easily navigate those structures and find the one which is useful to us. Okay, such as I want a title of the text. Okay, so I will use this line soup.title.text. Okay, extract and print the page title. Now in exception, if there's a scraping error, we just show it as normal exception block, nothing new. So already I've written this. The last line, okay, gets the page title. Also, I can use dot find method, dot find all method, and dot select method for deeper scraping. So you can use all this and more and more. I will talk about it in the end of the video. So coming to logging advanced errors for production app. Okay. So we have already touched this topic, but we'll deep dive. Okay. So why logging helps instead of print statement? Print clutter the terminal, whereas logging save the logs in a file. It tracks error in production. It also categorizes messages such as info, warning, error, or critical. Okay. So advanced techniques are, we'll use a basic config function to config the logging module, and then we'll log the infos. Okay. So first is logging.info. Format is this, right? So we'll create a, wait, let me just run this. Okay. So it didn't stored anywhere because we haven't set any file. Before it was, let's set the file to debug. File name, sorry, let's set it here. File name is equals to debug.log. Okay, now do it. Okay, now do it. Now it stores the, let's make it force. Yeah, it runs. So basically what I have done here is I've set the file name to debug.log. Format is this, and I forced it to switch it to the debug log, okay, file, and log the messages there. Okay, so it logs info, warning, and error with categorization like info, warning, and error. Okay, now coming to writing logs to a file. Okay, so how do we write a logs to another file? Just the same thing before. I've written the log, another file called app.log. I've zero division error. So let's log this into a app.log, and here zero division error, attempted to divide by 0. Now coming to rotating logs for large applications. For longer running applications, log files can become too large. Okay, so we can use a rotating file handler to manage them. See, when we are making a project and it runs for hours and hours, days and days, the log file can become very large. Okay, so we can set its size, we can set the backup count, means number of count that it will store, and the older versions will get deleted. So how to do that, let me show you. So from logging dot handlers, it's a handler module, we'll import the rotating file handler. Okay, now basic setup. Now we'll create a logging object here, which is using the get logger function, right? Then we'll set its level to debug. Okay, starting with debug. Now we'll set the handler here, we'll assert it with the rotating file handler, which is first is file name, then we'll set it max bytes, basically size of the file, and backup count should be 3, not more than 3. Okay, we can change it to 4 or 5, whatever. Okay, let's stick to 3. Now handler dot set formatter, this will set format to a handler. Basically we were setting format to a logging here, right? This is the format, remember? We are already setting format to a handler here, such as logging.formatter function. Then the format is this kind of message, basically time, level, and the message. We can interchange according to our need. That's how you do it. Okay, now finally we are adding that handler to our logger object using add handler function. Now just basic stuff, we'll log info, let's do it. Okay, it's run. See here, info application started again. Okay, let's change it to application started again. It does. Now once this app log file reaches this maximum byte of 5000, it will change its name to app.log to 1 and create another app.log and start putting the logs there. And once this backup count goes to 3 and the fourth one is about to come, it will remove the oldest one and add the new one. That's how it rotates logs. Basic explanation, it's written here. You can go through if you want to in the course file. Okay, so let's come to the summary of the module. Fine. So what's the summary? Silent failures, you can use logging assertion. Also, you can also use what? You can also use PDP, right? Okay, hidden issues, also use PDB module, right? And for debugging performance bottleneck, you'll use C profile, time mate. You can also use memory profiler. It is used for memory profiling, and we can see how much memory certain part of your program is taking, you know. So memory profiler, more of it. Okay. Exception handling in APIs and web scraping, you can use it using request module. Okay, you can handle HTTP errors. For web scraping, you can use what? Beautiful soap, right? You can use beautiful soap also. Now for logging advanced error for production app, you can use log files, rotating logs, and much more. Okay, so want to learn more about it? You can get exclusive resource right here. Okay, the link is in the description below where you can get my full Python course. It is structured, as we can see, module 1, 2, 3, and more is yet to come. And I've created a file links.ipy where you'll get curated learning links for this particular module 8, where you can deep dive each and every topic that has been taught here and beyond that. You can advance your skill much more and you can learn further and further. How much you want, that's up to you. So how to access? Just sign up with your email in the link description below and you'll get instant access to the course and the links. So what are you waiting for? Just go and sign up and get your resources and start learning. Okay? And also, now that we have conquered errors, if you want to improve your Python skills to the next level, stay tuned for the module 9 because we'll be working with Python libraries and don't want to miss that. Okay? Comment down below what's the worst bug that you have ever faced. Okay? And subscribe to the channel, hit that like button, hit that bell icon. And this is your vkpxr signing out. Catch you out in the next one. Peace.